Okay, so we're going to start with proof A here on the back side. So make sure you guys are paying attention as we go through this because we're adding something new today. I don't think this makes it significantly harder, but it does make it harder, I'll say that, because there's one other thing you need to be on the lookout for. And that new thing is right here where it says in the givens that PT is parallel to... Sorry, I'm just getting something going right here. So PT is parallel to SR, and I just highlighted that right there. I don't want you to highlight it yet because I just wanted to point out that this is not congruent. We're not saying these two segments are congruent. We're saying they are parallel to each other. And I'm actually going to get rid of that highlighting because I don't want you to get confused thinking that's something that you need to have in your paper. So that is one of the most common mistakes with something like this is that people will see that segment PT and segment SR and they'll automatically jump to the fact that they are congruent. Well, we don't know that they're congruent, so we can't jump to that. So make sure you're paying attention to the notation. It's especially evident when you compare the first one to the second one, okay? I know you can see the notation difference, but I'm just saying people skip over it all the time. So I have to make a special point of emphasis for that. These two are congruent, TQ and SQ. These two are just parallel. So, we'll just start writing the proof. And keep in mind, and I'll mention this at the beginning, when we have parallel lines, that opens up different angle relationships that we haven't seen before. Like alternate interior angles, corresponding angles, same side interior angles. All those parallel line relationships, all the transversal ones, those are things we need to be on the lookout for. If you look back at all the proofs you've done so far, it's really only been vertical angles if we're looking for angle relationships. But now we're going to have to look for some other ones. So that's kind of where this complication comes in. But if you know your alternate interior angles and corresponding angles and stuff like that, then you're okay. All right, let's actually get started with this. So we'll write our givens. So PT and SR are parallel. And TQ and SQ are congruent. That's given. So we'll just work through this one. I'm not going to tell you how many steps are in it, but I'll mention how many steps are in the remaining ones. All right. So TQ is congruent to SQ. Now, in that case, they are telling us two parts are congruent. So if you see that some element is congruent to something else, well, then you're good. You can use that. So I'm going to go ahead and mark TQ and SQ right here. All right. Another general comment that it's really important to make from the beginning is that all the proofs that we are doing today and what we've done so far, this is kind of the hardest way of doing a proof, which is, hey, this proof is completely blank. You need to think through the process from beginning to end. I've said this before, but I really want to reemphasize. It will get easier from here because you're going to get some practice next week where the proof is already half done. It's just fill in the blank for the rest. But I want you to be prepared as though it's the hardest way of doing it, where it's completely blank. Okay? So hopefully that gives you a little bit of comfort if you're looking at it today and you're concerned like, oh my gosh, this is really hard to do these proofs. Just keep in mind, for a lot of these on the test, you're going to have kind of some hints to help you along the way. All right. So let's go ahead and look at the next line. We'll worry about the parallel lines in just a second. So let's kind of go to the diagram and look for an angle relationship there. There it is, vertical angles. And again, hopefully that's something you guys can immediately spot. In fact, I encourage you real quick while we're writing this down to go ahead and look at the other diagrams on this page and see where you can automatically find vertical angles. You don't need to write anything yet, but just look at the diagrams and try and find all the vertical angles on this page. Okay, so we'll go ahead and write that. Vertical angles. And what are we going to name these angles? PQT is going to be congruent to what?
RQS.
There it is, RQS. So I showed that in blue, so I'll use blue. Of course, you guys have pink, yellow, blue, so whatever color you go with. And this question came up in first period, so I just want to really spell it out. Someone's asking, like, they're just still confused on exactly what it is we're trying to accomplish with these proofs. And our goal is to prove the two triangles are congruent. The only way we can prove two triangles are congruent is by finding three congruent elements between them. So that's why I'm constantly having you guys highlight. We found two. We're 2/3 of the way. We need to find one more congruent element, and then we can say they're congruent for one of those four theorems, for the reason one of those four theorems. Yeah?
So congruent angles, or no, wait, of course. I know what it is. Like, you see that arrow?
Yeah.
In between T and P, it is also on R and S. I just don't remember what it's called.
Okay, well, we'll talk about that one next. It is worth mentioning real quick that this PT is parallel to SR. They already have those marked, but on the test it won't necessarily be marked. So you'll want to go ahead and add those parallel markings. So imagine that wasn't there. Then you'd want to, and this might be the first thing you do before you even do anything else, but you'd go and add something like this. So anyways, knowing that they are parallel, what angle relationships can you guys find in this diagram? Alternate interior angles. It's a little bit hard to tell perhaps, but maybe if I did some erasing, and you can't do this, but maybe if I kind of got rid of that line right there and that line right there. You guys can't see it fully yet. Okay. Do you guys see alternate interior angles now? Okay. So it's a little bit difficult to see that maybe at first, but they are there. So go ahead and tell me what to name those angles. What did you call it? PTQ? PTQ and RSQ. I will say this is one of those exceptions where you could name it with 1 point. There's only one angle at T and S, but it's also a good habit to go ahead and name it with 3 anyways. All right, so those are congruent because they are alternate interior angles. So a while ago, I can't remember how long ago it was, I mentioned that alternate interior angles and vertical angles are the most common angle relationships you'll use. Also, there's reflexive property shows up a lot. But of the things that you need to notice in a diagram, these two are the most common by far, and we're seeing both of them in the same diagram. So just kind of, if you see parallel lines, maybe your brain should immediately think there's going to be alternate interior angles. You could be wrong, and we'll do a different example in a minute. But a lot of times it will be. Yeah?
How do you know which transversal to use?
And that's a good question. I was going to come to that, but I'm glad you brought it up. There are 2 sets of alternate interior angles. So notice that, well, I'll do it on the screen here. If I erased this, then I still have alternate interior angles. But now it's P and R instead of T and S. Either one of them works. And you'll be able to prove congruence either way. We just went with T and S. So just keep that in mind. And we'll talk about this. In fact, we'll circle around and talk about that again. But let's just finish this proof real quick. We've got 3 congruent elements. I've got my 3 colors used. So now, line 4. I can actually use I can write my triangle congruent statement. So triangle PQT is congruent to triangle RQS. As soon as I have 3 congruent elements, I can just write the triangle congruent statement. And then all I need to think about is which one are we using? Are we using... Okay. We can rule out side, 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 and side, angle, side. Well, we can rule that one out. So, now, yeah, it's, in this case, angle, side, angle. But I wanted to circle back around to what Logan said, because if I had used P and R instead, so I just showed you we have two sets of alternate interior angles. Imagine that my diagram looked like this instead. Instead of T and S, I used P and R. Which triangle congruence theorem is this? This one's now angle, angle, side. So the way we did it, we did angle, side, angle. But if we had used different angles, it would have been angle, angle, side. Does that make sense?
Yeah.
Okay, and I only mention that because there are multiple right answers. So I have an answer key at the front for what you're doing today. If you get up there and yours doesn't match, yours is likely still perfectly valid. You just kind of pick different angles to show we're congruent. And we could have done this even a third way, but let's not worry about that. So any valid way is acceptable, if that makes sense.
Could you show the angle, angle, side real quick?
Well, I just mixed it up.
I know which one's the angle, side, angle. I know how to find that.
Oh, angle, angle, side is just going to be a situation where there's two angles, but the side that's congruent is not between them. So whenever we had P and Q, then this side right here is not between those two. So that would make it angle, angle, side. Okay, we're going to skip ahead to D. So this kind of combines what we were doing yesterday and what we're talking about today. This is a lot of givens. I'm not going to write all that down. I will tell you this is going to be 5 lines long. So I'm just going to circle all this real quick and show that those are my givens. All right, now I'll go ahead and write our 5 lines. Okay, now nothing is given to me as far as congruence. I've got 2 sets of parallel lines, and I've got the C as the midpoint of segment AE. All right, so let's go ahead and get started. I say let's get started, but what do you guys notice? I want you to look at this diagram, see if you can find any angle relationships. What do you think?
Segment AC is congruent to segment BC.
Okay, AC is congruent to CE or EC. It doesn't matter how you name it. And what reason do we have for those being congruent?
Definition of the midpoint.
There you go. It's the definition of the midpoint. To reiterate what we talked about yesterday, if you have a phrase like we have definition, or that C is the midpoint of AE, you're going to use definition of midpoint at some point. And there it is. AC and CE are congruent. So remember, none of the givens are there without being needed. So we're going to need to know that both pairs of those lines are parallel. So what do you think that's going to help us with? Yeah, we'll be able to find some angles this way. Do you guys see any angle relationship? We don't actually have vertical angles here. It's not alternate interior. There it is. Okay. So this is one of those where it's the exception, maybe the exception that proves the rule, but we've got parallel lines, but if you look carefully, we don't really have alternate interior. Well, we do technically have alternate interior. We've got some alternate interior right here and here that I just marked, but that doesn't help us. So instead, Logan pointed out we do have corresponding angles. All right, so let's look at this angle right here. Where is the corresponding angle for it? DCE. All right, it's a little bit hard to see, and I can't turn the screen, but if you guys turn your page so those parallel lines are horizontal, it might be easier to see the corresponding angles. Okay? Is everyone able to see the corresponding angles there? How that works? All right, so I'm going to go ahead and start writing that. We've got corresponding angles. So, we've got, can anyone name those corresponding angles for me? Okay, BAC and DCE, yeah. So there you go. And I marked those in blue, so we'll go ahead and show that real quick. And we've got two congruent elements. Notice that the parallel lines that we used here were AB and CD. All right, so you can kind of see that parallel line and that parallel line gave me these corresponding angles. Does that make sense? There is another set. What I'm going to do real quick is I'm going to kind of check off that I've already used these parallel lines. So I've used that information. And remember, all these givens are here on purpose. So now we have the next one. BC and DE are congruent. So what's the angle relationship? That's also corresponding angles. But in this case, our corresponding angles are right here and here. Again, turn your paper so that the lines are horizontal and it might be easier to see the correspondence. All right, so let's name those real quick. Angle what? BCA is congruent to angle DEC. All right. Three congruent elements. Now we can write our triangle congruent statement. Triangle ABC is congruent to triangle CDE. And what's our reasoning this time around?
Angle, side, angle.
Angle side angle.
There you go. It's angle, side, angle. Again, we can rule out side, side, side. Honestly, side, side, side doesn't show up as much, and you've seen that because there's not a whole lot. I mean, anyways, it just doesn't come up as much for side, 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 but we can rule that one out because we only have one side. It's not side, angle, side either. So really it just comes down to angle, side, angle, or angle, angle, side. The side's between the two. So there you go. All right. And I just wanted to go through one more. And what we're going to do is look at E. So we've got two sets of parallel lines. And we might be able to go through this one a little faster. We're going to have 5 lines in this proof. So we can go ahead and write down 1, 2, 3, 4, and 5. We're going to pretend like this is a question on the test. So let's say you had this question on your test. It was completely blank, but I told you there were 5 lines. Well, we could fill in a few things right off the bat. We already know about the given, so I'll write that. A, B, and C, D are parallel. And then B, C, and DA are also parallel. Okay, the other thing we can fill in is what? The proof statement. So I'll go ahead and write that one in. So maybe this is the first thing you do on the test. You're like, let me just copy this information down. I don't know which triangle congruence theorem it's going to be. be side, 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 side on side. We'll just kind of figure that out. All right, so I heard someone mention some properties they notice. What? Okay, reflexive property. We can start with that one. We do have that shared side right in the middle. And obviously you kind of start just seeing what kind of diagrams use reflexive properties and which ones don't. So this is one that uses reflexive property. That's easy enough to write. That we've got that segment is congruent to itself. So AC is congruent to itself. CA. Okay. Next. All right, now we're going back to the alternate interior angles. And again, to make that clear, I'm going to do something that you guys can't do on your page, but I'm going to delete those two lines right there. And can you guys see the alternate interior angles now? Yeah. Okay, and maybe you could before too, I hope so. But now it's very clear. So, tell me what my line is going to look, or tell me what my statement is going to be.
BAC.
All right, and this is nice because these are labeled angles, 1, 2, 3, and 4. So if you have labels on your angles, you can use those rather than naming them. Okay, angles 2 and 4 are congruent because of what again? Alternate interior angles. I'll mark those so that we can keep our color coding going on. 2 and 4, and 3 and 1. All right. And just to see the 1 and 3, just real quick, I'll delete those lines. And if you get rid of those, then that alternate interior angle kind of, it's a nice beat. All right. Then that becomes a little more evident. Okay. So you guys have about 20 more minutes in class. Actually, a little more than that. But you've got some time in class. There are 3 that we haven't done. Oh, did we even finish this one? No. Huh. So let's finish that first. What is it going to be? All right. All 3 of these happen to be angle side angle, right? Or with, and that might give you a hint as to which ones are more common. And oh, I didn't color code this last one. Let me just, for completeness' sake, I'll do this. Okay. So anyways, you do have about 20 minutes left in class. There are some proofs on this page that we haven't done. I'll tell you how many lines are in each proof, and then you guys can kind of work through it from there. So let me go back to B right here. This one has 4 lines. So you can just kind of note that B has 4 lines. C has 5 lines. So B is 4, C is 5, and the last one has 4 lines also. There is an answer key at the front desk. I mentioned it, that your proof might not match the answer key, but come up and check it if you want to make sure yours is right because it doesn't match. Talk to me. Let me know if you have questions while you're working on it. But I'll let you guys move around if you want to work with some other people on this. And anyways, how about it?